it'll feel just like using Ethereum, right? For developers, it'll feel like just like building for Ethereum. Everything is in Solidity and you're pushing your contract to Ethereum. For users, everything's going to feel like Ethereum. You're using a wallet to make a transaction to Ethereum. And that's really how we thought about this, right? We don't want people to use something else. We want people to use Ethereum confidentially.
Rand, I think everyone listening to Bankless knows that crypto has a privacy problem. We want privacy. We don't have it yet. Here's how you put it in a recent tweet. You said, go to anyone on the street and ask them to show you their bank account. That's blockchain today. It's obvious we need confidentiality. Why don't we have privacy yet?
Well, I think if you look at the history of blockchain, maybe the first thing we have to understand is why is data public in the first place? The reason why data is public on a public blockchain is because you want public verifiability. If you want anybody to be able to recompute the state, they need to be able to use and see the data that was part of computing that state. And so there was really no other way if you wanted decentralization and public verifiability, but to make the data public. This was never a feature of blockchain, right? It was kind of like an artifact of not having homomorphic encryption and these techniques 15 years ago. But what you really want is public verifiability. And I think there are many, many attempts to doing that. For example, some early privacy protocols like Zcash. Big fan of Zcash. You know, I've been a long time holder. I'm very happy it's finally happening.
Yeah, it's finally happening.
Right? It's
Ron
like,
Paul
yes,
style, yes.
I was right. So Zcash used zero knowledge proofs as a way to effectively prove that you had the tokens that you wanted to transfer, right? And so in this case, what you would publicly verify was the proof. You didn't need the data. But the problem is that you didn't have composability on this proof. So you were stuck with basically just doing confidential transfers. And I think this is why a lot of other people started looking at other techniques like FHE, like multi-party computation, like Tease, to try and create this shared private state that you could build DeFi on, that you could build other blockchain applications.
For the non-cryptographers, Rand just mentioned Tease and multi-party computation, all of that. Don't worry, we will define those things. And I hope we will simplify those later in the episode. But let's stick on this for a moment. So I think you're saying, Rand, that the reason we had public blockchains in the first place, and they were constructed as such, is because we were tech limited. We didn't have the cryptography at the time. I mean, there are a couple of other explanations I can think of. Certainly tech limited is one of them. There's also maybe demand. Maybe there's just not demand for privacy and confidentiality. That's a possibility. A third possibility is the regulators wouldn't let us. This is kind of a sort of a counterfactual, historical counterfactual I've often thought of, which is the basic idea that if Bitcoin launched in a private way, governments would have strangled it in the crib. It would have never been able to rise to the degrees that it is today and get acceptance today. What do you think it is? Do you think it's all the tech side, or do you think there's a balance of these other two as well?
You know, I think that's a very interesting question. I've been in privacy for a very long time, actually. My previous company was already working on privacy for AI. So I've been thinking about this problem of how do you make, services private? And nobody really cares about privacy because most of your life isn't publicly visible to other people. When you go to your house and close the door, nobody sees what you're doing inside. When I'm on my phone, I'm using an app, everything I'm doing on my phone isn't broadcasted to the public. So it wasn't really something people had to think about because it wasn't something so visible as it is in blockchain. I think it's not that people didn't want it in blockchain, it's that they didn't really have much of an option. And for a long time, we were told that having anonymous addresses was enough. But clearly this is no longer true. You go on a website like Arkham, you type your name, you'll see everything that people can find about you on chain. Like, that's really scary, man. Like, I come from France, a country where we had 10 crypto kidnappings. Like, you don't want this data to be public in those instances. I think it's just that we're getting now to an inflection point where privacy is no longer something that people can afford not to have on blockchains because the amount and volume of assets are such that we need to start taking this seriously. And of course, finance moving on chain, like there's just no way that a bank is going to use stablecoins for bank accounts if your neighbor can see your bank account. It's just not going to happen. I don't even think it's legal in that sense.
So you think the demand has always been here? We've been more tech limited. Maybe we'll talk about the regulator, kind of the nation state limitations later in the episode.
I think a good example to illustrate how quickly the mentality can shift around that. If you remember, before Telegram, before Signal, we didn't have any encryption in messages. When I sent you like a text message over like SMS, this data was not encrypted. So it was completely visible to anybody on the network effectively. And then Telegram came about a time of Snowden made the revelations in 2013. Telegram came and said, hey, you can encrypt your messages. Everybody started adopting it. Then WhatsApp added encryption by default. Then Signal came out. And now it would be unthinkable to use a messaging app that isn't encrypted.
I mean, thank God, right? Thank God for that.
Yeah. But nobody asked it. SMS, text messages have existed since the 80s. Nobody was asking for privacy until people realized, oh, I can have the exact same service, but private. Why would I not do that?
You can now borrow USDC against your Ethereum and Bitcoin on Coinbase. Crypto-backed loans on Coinbase make assessing liquidity seamless for crypto hodlers. Powered by Morpho, Coinbase crypto-backed loans gives you direct access to on-chain financing, allowing you to take out loans at competitive rates using your crypto as collateral. Over $1 billion in loans has been opened through Coinbase to date. On the Coinbase app, eligible users can borrow up to 1 million USDC using Bitcoin or Ethereum as collateral. Users can convert their USDC into fiat to make down payments, refinance debt, or cover urgent expenses, and more. The benefits are numerous. Interest rates are variable, typically between 4 and 8%, and respond to market conditions. Loans are approved in seconds without credit checks. Repayment schedules are variable, meaning there are no fixed deadlines. The kicker? Coinbase will not treat borrow transactions as taxable events. Manage loans directly in the Coinbase app with ease. It's currently available to US customers, except New York, and additional collateral types and increased loan limits are coming soon. Want to learn more? Click the link in the show notes or visit coinbase.com/borrow. Introducing FRAXUSD, the genius-aligned digital dollar from Frax. It's secure, stable, and fully backed by institutional-grade real-world assets, custodied by BlackRock, Superstate, and Fidelity. It's always redeemable one-to-one, transparently audited, and built for payments, DeFi, and banking. The best of all worlds. At the core is FRAXNET, an on-chain fintech platform built to align with emerging US regulatory frameworks where you can mint, redeem, and use FRAXUSD with just a few clicks. Deposit USDC, send a bank wire, or tokenize treasuries, and receive programmable digital dollars straight to your wallet. FRAXNET users benefits from the underlying return of US treasuries and earn just by using the system. Whether you're bridging, minting, or holding, your FRAXUSD works for you. Frax isn't just a protocol, it's a digital nation, powered by the Frax token and governed by its global communities. Join that community and help shape Frax Nation's future by going to frax.com/r/bankless. Frax, designed for the future of compliant digital finance. Ethereum's layer 2 universe is exploding with choices, but if you're looking for the best place to park and move your tokens, make your next stop UNICHAIN. First, liquidity. UNICHAIN hosts the most liquid UNISWAP v4 deployment on any layer 2, giving you deeper pools for flagship pairs like ETH USDC. More liquidity means better prices, less slippage, and smoother swaps, exactly what traders crave. The numbers back it up. UNICHAIN leads all layer 2s in total value locked for Uniswap v4. And it's not just deep, it's fast and fully transparent, purpose-built to be the home base for DeFi and cross-chain liquidity. When it comes to costs, UNICHAIN is a no-brainer. Transaction fees come in about 95% cheaper than Ethereum mainnet, slashing the price of creating or accessing liquidity. Want to stay in the loop on UNICHAIN? Visit unichain.org or follow @UNICHAIN on X for all the updates.
And I guess that transformation to end-to-end encryption over communication, that felt very natural. That felt very organic. That was not like stopped in a big way. Yeah, there was a moving of the Overton window. I want to ask about terms here, because I've heard you talk about like privacy, certainly, but then you also use the term confidentiality. And I think we'll probably come back to these two terms throughout the episode. But are they interchangeable? Is privacy and confidentiality, are they synonyms? Are they basically the same thing? Or is there some distinction between those words I'm missing?
So I use confidentiality more often than privacy because it's a larger set of application. When we talk about privacy, we typically talk about personal data, your bank account, your DNA. This is personal data. You want it to be private to you. When we talk about confidentiality, we include data that is not necessarily about someone, but it could still be sensitive. A company's statement, or maybe, I don't know, like you're playing cards and you want to hide your cards in poker. You need confidentiality for that to even be possible, but it's not technically privacy in the sense of personal data. So confidentiality is just like a bigger, more generic term of which privacy is specifically about personal data.
Okay, so confidentiality is then a superset under which privacy exists. Yes. But when you say confidentiality, you're not implying something lesser than privacy. Are you implying that, most parties don't have access to it, so it's non-public, but there are some parties that can access the data. Do you know what I mean?
I can see how because we sometimes think about confidentiality in like a business setting where it basically means a confidentiality agreement.
Yeah.
But the term confidentiality actually means just, not public effectively. So I use it at least as a superset of privacy.
Okay. And so we might use these as in the episode with the listeners understanding that we might be use these interchangeably throughout the episode. Now, the reason I wanted to have you on today is because I feel like privacy is having a little bit of a moment right now in crypto, thank God, which is great. And I think that what you're doing, we'll certainly get into what you're doing, but I want to frame this out because the reason we're doing this episode is because I think, Rand Hindi, you are trying to bring privacy to every Ethereum transaction. At least if I said that, if I made that claim, Rand, is Zama your project? Are you seriously planning and trying to bring privacy to every single Ethereum transaction? If I said that, how correct is that statement?
It's correct. Just it's not limited to Ethereum. We want every blockchain transaction to be encrypted. So the way that we are building Zama is as a layer of confidentiality on top of existing blockchains. So instead of launching a new chain that would be private on which you would need to bridge your assets, we basically add this layer of encryption to Ethereum, to Base, to Solana, to anywhere where people want to run and do something, on chain. And so I think that's really interesting because if I tell you you've got stablecoins on Ethereum and you can now shield them into confidential stablecoins where your balances are encrypted, the amounts are encrypted, but they're still on Ethereum, you have all the benefits of Ethereum's liquidity, Ethereum's security, without actually the data being public on Ethereum anymore. I think about it a little bit like HTTPS, but for blockchain. HTTPS, when you connect to a website, the data you're sending and receiving is encrypted, but you don't really actually notice it. You're still just connecting to a website. This is the same idea here for blockchain transactions.
Bringing confidentiality, bringing privacy to not just every single Ethereum transaction, but also to every single blockchain transaction, whether that's in this Solana ecosystem, other EVMs, other layer 2s. That sounds like a holy grail, okay? And we'll get into how this is possible because that'll be the rest of the episode we're sort of teeing up. But I want to make sure I understand what you're actually saying. So if I'm on Ethereum and Zama is deployed, like this works, then will there be a button inside of my crypto wallet, inside of my Rabby, inside of my MetaMask, where I can basically go incognito and send this specific transaction privately, confidentiality? I don't have to bridge to a whole new chain. I don't have to do a thing. It's just integrated into my self-sovereign DeFi wallet experience. That to me is the holy grail. And I just want to be clear. Is that what you're saying?
That's exactly what we built. And actually, you know what? I wish I could hire you for marketing because you're saying it in such a way. I got excited just listening to you talk about it. I was like, that sounds like a cool thing. Yes, that's exactly what we actually did. And I know it sounds incredible because it doesn't seem like this would even be possible. Like, how can you have privacy on a public blockchain? But that's exactly where those new cryptographic techniques like FHE actually come in, right? This was the missing piece to enable exactly that vision. I've been in crypto since 2013, right? So I've seen many, many, many cycles. I don't want to have to use a new protocol. Like I'm happy on Ethereum. Like I've been an ETH maxi for a very, very long time. Like, and that's where I want my money to be. But I don't want it to be public. And so in a way, I just kind of solved the problem for myself by building this at Zama too.
Well, and the excitement is you're solving a problem for me and a ton of Bankless listeners, basically, if this works. Now, let's talk about, because this sounds almost too good to be true, Rand. And so now we get into the more nerdy part of the episode. So you used an acronym there, which is a cryptography acronym called FHE. I believe that stands for fully homomorphic encryption. All right. So it's not something that you'll probably be able to bring up in a dinner time conversation. No one will know what you're talking about, but I want to do a quick 101 on cryptography. So can you take us through the main families of cryptography in crypto and help simplify this? I don't know how you would list this out, but I guess my mental model, I have kind of a list of maybe 4 families. There's sort of the classic cryptography of Bitcoin. These are things like hashes and signatures. Then there's this whole field of moon math, with Justin Drake just came on the podcast. He calls this snarks, succinct proofs, or like ZK, right? ZK snarks, that whole section, and that has some magic. So that's the second. Then we also have this thing called multi-party computation, I believe. MPC is the acronym for this. That's another thing. And we also have FHE, which is what you're talking about. And this is what enables some of the holy grail that you've just been talking about. Can you break this down, give some detail here without getting too far in the weeds? How can a layman think about each of these families of crypto and what are their superpowers? And then we'll get into how FHE fits into this.
So I think when you think about cryptography as a field, there are, I would say, big kind of ideas. One of them is I want to be able to store data securely in a way that nobody can see it unless they have the secret key. So that's typically what you have with traditional encryption. When you're encrypting data that you're storing in a database, you're using AES to do that. Then there is, I want to be able to communicate a message to someone without other people being able to eavesdrop. So secure communication, what Signal is doing, for example. That uses another type of encryption, which is slightly different than what you have in storage. Then you've got the whole field of like, I want to authenticate myself. I want to prove that I'm the owner of that particular thing. That's where signatures comes in, whether it's like, ECDSA or other types of signatures. When you sign a transaction on Ethereum, you're using a key to prove that you're the legitimate owner who's allowed to do that, right? So that's another field. And then you've got, I would say, more like cryptography 2.0, which is related to how can I go beyond transmitting, storing, and authenticating things? How can I compute privately? How can I share a secret privately? How can I prove it?
So everything you just described, Rand, is basically what I call the classic family. And
that's the classical cryptography.
Yeah, and that's what Bitcoin and Ethereum have been based on to date.
Exactly. And then you have what you call the moon math cryptography, in which I would actually include all of those new advanced techniques, zero knowledge proofs, ZK, fully homomorphic encryption, FHE, multi-party computation, MPC. All 3 of them are very important, but are used in different ways. ZK is a way to prove that you've done something without necessarily revealing the data that's behind it. So I can prove to you that I have 100 tokens without showing you that I have 100 tokens. That's what Zcash does typically. Very, very useful in many applications. The only downside of ZK is that you cannot compute on the ZK proof. So you don't have like composability. You cannot stake that proof. You cannot do this kind of things. If you want composability, if you want like a state on which you can compute, you have only 2 solutions: multi-party computation or fully homomorphic encryption. MPC is used very often for wallets, for secret keys, because it gives you a way to split the secret key with a bunch of different people that have to effectively talk to each other in order to do something. So think about it as like decentralizing the private key.
When people are thinking about decentralizing the private key, maybe they're thinking about something like, the seed phrases to set up a crypto wallet, right? That's the English word mnemonic, and is basically, you can derive a private key based on that. So MPC splits those words up across multiple parties? And is it some majority of these parties have to kind of share the data in order to reconstruct the private key? And what is a private key in crypto? Of course, it's a key to a safe. So you can open a safe if you have enough of these parties agree to open it.
So MPC, the way it works is the key is never reassembled. The point is that the key is never in one place, right? The key is split in a bunch of places, but each individual person does a piece of the computation. And when you put it back together, you get the actual result of having used the full key.
Kind of like a multi-sig in a way, like conceptually.
Conceptually kind of like a multi-sig, right? Okay. You need all the different parties to be involved to get the actual end result. That is by far the best thing that we know of for managing a secret key. But it's not very easy to use that if you want to compute, because it doesn't scale very well with the number of people involved, right? So effectively, the more people are splitting the key, the slower the system actually gets, because they have to talk to each other.
On MPC, so I think people are aware of ZK, sort of ZK proofs and where that's being used, like Zcash, it's being used for privacy. Also, we've done a ton of content around scalability. Justin Drake and kind of the next lean Ethereum roadmap is all about using ZK snarks for scaling Ethereum. So it's really good there. On the MPC side, I think I've seen it in different wallet constructions. So Coinbase has some MPC wallets, which are
Fireblocks.
Fireblocks, right? And most recently, that X402 protocol, which is just like agent to agent or like machine-based like transactions, which is super cool. I saw a demo of Coinbase where you can sort of attach an MPC wallet to your ChatGPT interface and have ChatGPT go buy stuff online for you from your crypto wallet. And I guess in that construction, the MPC wallet is what? Like, who has the ability to sign a transaction? Is it you locally and then also Coinbase somewhere? Or like, what is that?
It depends who are running the different nodes.
I see.
Right? So we actually use it in the Zama protocol when we want to decrypt something. Let's say someone wants to see their encrypted balance on Ethereum. Someone has to decrypt this encrypted balance. So the way that we address that problem is that we have the decryption key that is split between 13 different entities. And those 13 entities are extremely reputable people. Ledger is one of them. Fireblocks is one of them. Layer 0 is one of them. So, we're talking companies that collectively secure 100 billion in assets already, which are responsible for like the decryption key in the Zama protocol. You need 2/3 of them to participate to get a decryption. So if someone wanted to cheat, they would need to hack 2/3 of those companies, in which case, to be honest, you can probably steal most of crypto, custody assets that people have anyways. But if you want that to be performant, you have to use it for very, very specific things. So we only use it for decryption and nothing else. And that's what brings me to FHE. FHE is a way to compute unencrypted data without decrypting it. So I give you a piece of encrypted data, and I can now run software, a smart contract, an AI model on the encrypted data, and the output is also going to be an encrypted piece of data. So it's like end-to-end encryption, but for any kind of software that you might want to be using. And so if you're talking about a blockchain, it means that your state is encrypted, but you can still have a smart contract that modifies that state without having to actually see it.
Now, Rand, I take you as almost a little bit of a FHE maxi, and I say that in a complimentary way. And I think maybe your take is different from some other takes that I've heard. You put it this way: FHE for privacy, ZK for scaling, MPC for key management.
Exactly.
And this is the optimal blockchain stack.
Yeah.
So you really think FHE is the primary cryptography to bring privacy to blockchains rather than ZK? And some people will hear that and say, wait, hold on a second, Rand. I thought ZK was not only the scaling technology, but also the privacy technology, right? The solutions that we see out in the wild for privacy on blockchain today, they're all ZK based. So the Z in Zcash is, ZK. And something like Tornado Cash or you like Railgun. These are all ZK type solutions. I believe even the Aztec protocol, which we'll talk about maybe in a little bit, it's all ZK. So why are you doing FHE rather than ZK?
So when you're looking at a blockchain and you want, confidential blockchains, you want three things. You want the encryption that you're using to be safe, to be secure, right? So you want something that can withstand any kind of cryptographic attacks, even quantum computers. So today, FHE is secure even against quantum computers. So even a quantum computer cannot decrypt your data on chain. That's really important. It's also the case, by the way, for MPC, and is the case for some of the ZK stuff, not all of them. So that's one thing. The second thing is you want public verifiability. People should be able to recompute the state and verify that it's correct. ZK gives you verifiability, obviously, because anybody could verify the ZK proof. FHE gives you verifiability because anybody can rerun the FHE computation and verify that the encrypted result is correct. MPC doesn't give you public verifiability in that sense. And the third one is you want composability. There's not much point using a blockchain if you can only do one thing on that chain, right? Ethereum's, I would say, big breakthrough and kind of genius was to bring programmability to blockchain, which didn't exist before. If you remember, before Ethereum, every coin was its own blockchain. Ethereum gave you a way to program the blockchain using smart contracts. So you really want this programmable privacy, this kind of composability feature, and ZK doesn't offer that. For that, you only have MPC and FHE. So it's not that I'm like an FHE maxi. It's just that if you look at how do you take an existing blockchain, not change it, but add confidentiality to it, FHE is actually the right way to do that.
So you're not an FHE maxi. You just think FHE is a better fit for purpose for the blockchain constructions that we have. Is there some beef between ZK people and FHE people? I just tangentially view this, but there's Eli Bansasson, of course, a Starknet godfather of ZK, absolute legend.
I love Eli, by the way.
Yeah, so Eli says some pushback, right? He's pushing back on the idea that FHE is best for privacy. He says two problems with the FHE. You need the nodes of the chain to do the heavy lifting of computing the FHE because FHE gives privacy but not integrity. If you need integrity, you either need to trust the FHE operator or add ZK to the mix because ZK does prove integrity. That's the first problem, he says. The second problem is the silicon and scale needed are pretty large, especially at scale. You're talking 100,000 TPS, and you don't need two nodes to run it. This might be a typo there. Hurting decentralization and scale. So he's saying it's hard to scale, and he's also saying there's some trust implications when you use FHE. What's your response to that?
I mean, that's a very fair point, right? And I think, those problems exist for sure. And these are the hard problems that Zama has been solving. So integrity, the way we look at it, this is a blockchain problem. If you run consensus on the FHE computation, you get integrity, right? If 100 people run the computation and agree on the result, you can basically say the result is correct. So FHE in that sense can benefit from all of the existing blockchain paradigms for achieving integrity. Consensus, optimistic proofs, ZK proofs, whatever the flavor that you're using to have integrity on the state, you can have integrity on the FHE computation as well. So from that sense, I don't want to say it's not our problem, but this is a problem that blockchain have already solved. If you look at performance, historically performance in FHE was a big bottleneck. It took minutes to do a confidential token transfer a few years ago. But today, we've actually made FHE about 1,000 times faster than when we started a company 5 years ago. And we're on track to get a 10x improvement year on year on performance. So we're actually launching now on Ethereum with more capacity than mainnet can support. So all of Ethereum we can do encrypted in FHE today. And moving to GPUs, we can get to 1,000 TPS. So FHE is not really that compute intensive if you look at something like ZK. I think actually I looked at the numbers. The cost of an FHE token transfer, infrastructure-wise, is $0.00001, right? So like 100,000th of a dollar. And it takes like 20 milliseconds. So you're going faster than the communication between the consensus nodes in the first place. It's not really a problem anymore. It was a problem, but we solved that problem.
So on scaling, you have more recently, scaled up performance such that the Ethereum network can handle like 20 to 30 transactions per second. You can support far more than that in Zama, for instance. Like, can you support the thousands of TPS? Thousands right now.
We're launching on CPU first, because as much as I'd like Zama to have 1,000 TPS on day one, the world doesn't work like that. There's a bit of a ramp up for people to start adopting those new confidential products. But moving to GPU, which we're planning for early 2026, we are estimating we can get anywhere from 500 to 1,000 TPS per chain on which we're deploying Zama. So 500 to 1,000 TPS on Base, on Solana, on each of them. I think that buys us quite a lot of time so that we can work on the next phase, which indeed will require work, is building a dedicated chip for FHE, an ASIC for FHE. That sounds a little bit crazy to say we're going to build a chip for FHE, but I mean, we've done
it for
crazy. Yeah. Bitcoin mining is ASICs basically. So, and the FHE chip is comparable in complexity to a Bitcoin miner. And that will give you 100,000 TPS on a single machine in a data center. So one server, one box in a data center would be enough to power global payments on chain with FHE at a fraction of the cost of running a GPU server. So FHE is not a problem anymore. It's just a compute problem, which, by the way, is just a money problem. If you throw more money at compute, you're going to get better compute, you're going to get better performance and bigger addressable market for this technology.
I mean, this seems like a similar story to what we're seeing with like ZK prover, times and that kind of thing, where it's a combination of software and hardware that's like making that possible. And those are the ingredients here. You guys are optimizing kind of the software layer and also the hardware layer to like squeeze out as much scale as possible.
Exactly. So ZK and FHE are following very similar scalability paths in terms of making it better. It's just that in practice, there are fewer people that were able to construct secure FHE protocols. I think, today, I think Zama is probably the only FHE protocol that is secure in production. 9 out of 10 people doing FHE are actually using Zama's technology somehow. And there is a reason for this, is that FHE is a very hard problem, like a very, very hard problem. And I have no credit for it, by the way. My co-founder is like Pascal Payet, like he invented one of the early homomorphic encryption schemes that, like, the Payet scheme has his name. And we've got like 37 PhDs in the company. And these guys are like far smarter than I am, but it's a hard problem. Like, it took years to make it work. It took years.
So back to at least like first point. So that's the scaling point. His first point, and you guys use this term integrity, which sometimes throws me for a loop. We're like, what does integrity mean? Actually, in the context of data, I get that it has a definition. This was meaningful to me. He said, you either need to trust the FHE operator or add ZK to the mix. Is the trust the FHE operator, is that why in the Zama construction you just mentioned, you have 13 different entities, kind of trusted entities that are running some of the Zama nodes, and you have this MCP construction between all of those 13? Is that what he's referring to? Is this something else?
No, not exactly. So there are two parts of how you build an FHE protocol. There is, how do you compute on the encrypted data, and how do you decrypt the encrypted data? So there are like two things: computation and decryption.
And you need to decrypt it because the user wants to decrypt
the user wants to
their own data.
Okay. Right. You want to know how much money you have. So for the decryption, that's where you use the 13 MPC protocol.
I see.
It's just for decryption. For computation, you can have as many people as you want doing the FHE computation because everything is publicly verifiable. So anybody could participate and can basically say, I'm going to compute it, and can effectively do like a consensus, like any existing blockchain. So when you want integrity on the FHE computation, either you just ask a bunch of people to do it and you compare the results, or you can use a fraud proof. So one person does it, but anybody could verify it and basically say, oh, that person cheated, needs to be slashed. Or you can use ZK and basically do a verification of the FHE computation. So there is absolutely no difference on how you handle FHE computation versus existing blockchain smart contracts. Every single technique that we use for integrity in blockchains, you can use for integrity in FHE.
Okay, and these sort of, I'll call them weak points of FHE. That's the entire purpose of Zama. I mean, we'll get into the Zama construction later, but the like encryption, part and the decryption part, that's what you're sort of, I guess, smoothing out the rough edges there in the Zama protocol and creating a mechanism so that everything is secure and maintains confidentiality in both those parts of the process. Is that correct?
Yes, exactly. You want to think about this not as separate things, but as an end-to-end protocol. You cannot dissociate the decryption from the computation from the blockchain. So, for example, the way that you know that someone can decrypt a value is because you have a smart contract that explicitly says this user can decrypt this value. If the smart contract doesn't say so, the protocol will reject the request for decryption. And so you see how everything kind of becomes intertwined, right? Like you have people doing FHE computation, people doing threshold decryption, you have a blockchain where all the logic and access control actually lives. And you have to analyze this as an end-to-end system to know whether it's secure or not. And fortunately, there are actually mathematical proofs that you can have that the system, from a cryptographic perspective, is secure. And so Zama actually achieved that. Zama achieved what's called the strong IND CPAD security. Like, it's a mouthful, but basically what it says is there is no known attacks that can break the cryptography of FHE. So the only issue can be a software bug in the implementation, of course, or it could be people didn't do the job they're supposed to do. But the cryptography in itself is mathematically proven to be secure as long as people do what they're supposed to do.
So does this answer the question of, again, I'm not smart enough, Rand, to field these questions to you, so I'm using other cryptographers by proxy. So Ian Myers, he's a CS professor, security and applied cryptography. He said this, there's no such thing as fully homomorphic decryption. Of course, we've been talking about fully homomorphic encryption. He says there's no such thing as fully homomorphic decryption. Anytime you see a system using FHE to compute on your sensitive data, remember, someone has the key. And if it's not you, do you trust them? This is the 13 entities essentially in the Zama protocol that do have the key.
Exactly. No, so Jan is right? Yeah. In FHE, someone has to decrypt. And so instead of having like a trusted central party do that, that key is split between 13 people. Those 13 people, everybody knows who they are. Ledger, Fireblocks, all of these guys. If those guys cheat in the Zama protocol, first of all, they have to be able to do that, right? So you need to have 2/3 of them colluded. So we're talking about 10 out of 13 of the most reputable companies in crypto that are responsible for 100 billion in assets, calling each other on the phone and being like, "Hey guys, let's cheat to read to know how much money Ryan has." I mean, sure, right? It's not ideal, but it's as good as it gets. And it's actually how most of the world works. The internet, it's crazy people don't realize that. When you connect to a domain name, right, to bankless.com, that domain, bankless.com, is converted to an IP address so that the internet knows where to send people. There are 13 companies responsible for this. So the internet runs on 13 companies, right? That's insane. And it works. So I think, we're doing the best we can with existing techniques. And today, Zama, the way it's implemented, this is as state-of-the-art and as secure as cryptography allows you to build. Like, we didn't take any shortcut. If anything, we've actually done things that were never done previously anywhere in the world, cryptography-wise.
Yeah, I like it. I mean, there's definitely a practical, implementation that you've done. And I mean, just to be clear, so these 13 entities, it would require 2/3 majority. You really can't imagine them calling each other on the phone and just being like, hey, I really want to decrypt Ryan's, blockchain.
If they didn't get caught, the business would go to zero. Like who would use a Ledger wallet if Ledger cheats in Zama?
But let's push back on that a little bit, because it probably wouldn't happen that they are all kind of in a cabal and turn evil. The way it would happen really is like some government, right? You get, like OFAC calling in the 3-letter agency calling you and saying you got to decrypt this data. Okay, we'll bring court orders against you. We'll make life really hard for operating in our country if you don't. What you're doing is illegal unless you decrypt it. It's probably going to be nation state level attack, which is like, I'll put that out there and I'll just say that's going to be fine for the majority of use cases that people do, probably. But that is a vector that they could get into something like Zama, for instance.
That's a very fair point. And so I think about this a lot. Honestly, I think I'm spending hours a day trying to think about how to make this thing more resilient to global catastrophe and attacks against it. So the first thing you can do is those operators, you can try and pick them in a way that they're geographically distributed. Some US, some Europe, some Asia. So the more geographically distributed, the harder it is for a government to do this. So you would need like a coalition of governments to do this kind of stuff, right? So sure, is it possible that the US, has a deal with 50 other countries on surveillance? Maybe, right? That's possible. But you see, you're already adding like one layer of complexity because you're talking about global political coordination to make this happen. The second thing we're doing is we're actually locking out the operators from accessing the secret key that they're holding. So the way we're doing this is the MPC nodes, all 13 companies, they have to run inside what's called a hardware enclave. So the actual software is running inside a container that adds another layer of security. So it's not just that you would need 2/3 of them to be corrupted, you need 2/3 of them to break the hardware faster than they would be detected, and the protocol would basically kick them out, right? And on top of that, there's also encrypted communication between those different nodes to make sure that they're running the correct version of the software each other. So they would need to run the incorrect version of the software to break, the hardware kind of like container they're in. They would need 2/3 of them to collude on an international coalition of governments to make that happen, and not get caught during that meantime that, we would just basically kick them out and replace them with other operators. I think, to be fair, like if that's your threat model, you're probably not going to be using the internet for anything. Let's be honest. Like, there are far fewer.
Or, you're probably like North Korea or something like that, right?
I don't think North Korea can pull this off. Honestly, I don't think North Korea can pull this off. Like, the truth is, no matter how much people don't like to talk about it, there's always going to be, when you talk about security, when you talk about anything, there's always going to be a trade-off somewhere. The question is, you have to make the trade-off so high that it's either extremely unlikely or extremely expensive or extremely, I would say, like disruptive for someone to actually do that.
Yeah, I think that sometimes people, think in terms, they think in terms of binaries, right? And they don't think in terms of like good, better, best, right? Things that are, and if you just think about the status quo, which is we have no confidentiality on any transaction. And if you actually want confidentiality, and for the practical crypto user, they're doing something like they're moving their assets from one address to Coinbase and then moving it back out in an attempt to kind of obfuscate their traffic. What is that? And the upgrade of just having a confidential button inside of your wallet that has these, that uses Zama, that is just like a 10x, 100x better than the status quo.
Look, it solves problems that are unsolvable otherwise. Like the trade-off that Zama has to make, there is no other solution. It does not exist. You cannot have composability unless you figure out a way to have like a shared secret state. And the way we are doing it, honestly, like it's most people think I'm over the top and how many layers I'm adding to this thing to make it really, 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 really hard for people to kind of read your balance.
Well, that's the thing. If you make it incredibly easy, like current privacy solutions are pretty difficult. So even something like Zcash, you have to go to an entirely new chain in order to do that. And you have to basically, if you want your store of value inside of Zcash, you have to like buy a coin. I mean, Amin Soleimani put it this way. It's like, I shouldn't have to buy someone's Ponzi scheme in order to get privacy, right?
I wouldn't call Zcash a Ponzi.
Use a little tongue in cheek, right? But it's mimetic money. I shouldn't have to buy another store of value asset that could fluctuate, 10, 50% in a given day in order to just get some privacy on the assets that I really want to hold.
No, what you want is encrypted. You want encrypted dollars on Ethereum.
Yeah,
right.
That's right. That's right. And so if you're bringing this to more people and creating an easy button for that, that's a net win. I guess so. We've talked about these families of cryptography. Are there other ways to kind of smush these things together? So you're talking about like every operator has a secure enclave. I don't know if that's like TEE or what that is, but like, are we able to like, even the tweet I was referencing from the Starknet founder talked about, well, you could just add ZK to some of the FHE stuff and get even stronger guarantees. Can we layer this cake somehow and get even better?
100%. I mean, this is what we're doing. It's funny because people think about Zama as a purely FHE company. So, out of like 30 or so researcher, I have like 6, 7 of them doing MPC, 5 of them doing ZK. Zama uses FHE for the computation part. But actually in the protocol, as I mentioned, there is MPC for the decryption. There's even some ZK stuff we're doing like for integrity security stuff. So, this is not like the primary component. These are like Lego blocks that you're putting together to build an end-to-end secure privacy layer, right? So yeah, 100%. Like, as I said, I'm super pragmatic. If tomorrow someone comes up with a better technology than what we've got, we're just gonna use the ideas and then try to implement it to make things better. Like, whatever works, that's the bottom line.
Imagine a world where traditional finance meets the power of blockchain seamlessly. That's what MANTLE is pioneering with blockchain for banking, a revolutionary new category at the intersection of TradFi and Web3. At the heart is UR, the world's first money app built fully on-chain. It gives you a Swiss IBAN account, blending fiat currencies like the euro, the Swiss franc, the United States dollar, or the renminbi with crypto, all in one place. Enjoy real-world usability and blockchain's trust and programmability. Transactions post directly to the blockchain, compatible with TradFi rails, and packed with integrated DeFi features. UR transforms MANTLE Network into the ultimate platform for on-chain financial services, unifying payments, trading, and assets like the MI4, the METH protocol, and Functions FBTC, backed by developer grants, ecosystem incentives, and top distribution through the UR app, reward stations, and Bybit launch pool. For MNT holders, every economic activity in UR drives value back to you, embodying the entire stack and future growth of this super app ecosystem. Follow MANTLE on X at @mantle_official for the latest updates on blockchain for banking. That's x.com/mantle_official. Crypto is risky. Your sleep shouldn't be. 8 Sleep's mission is simple. Better sleep through cutting-edge technology. Their new Pod 5 is a smart mattress cover that fits on the top of your bed. It automatically adjusts the temperature on each side so you and your partner can both sleep the way that you like. It's clinically proven to give you up to 1 extra hour of quality sleep per night. 8 Sleep's Pod 5 uses AI to learn your sleep patterns, regulate temperature, reduce snoring, and track key health metrics like HRV and breathing. With a new full-body temperature regulating blanket and built-in speaker, it is the most complete sleep upgrade yet. Upgrade your sleep and recovery with 8 Sleep. Use code BANKLESS at 8sleep.com/bankless to get up to $700 off the Pod 5 Ultra during their holiday sale. That's 8sleep.com/bankless. You also get 30 days to try it risk-free. Link in the show notes for more information.
Whatever works, that's the bottom line. You also have another bottom line tweet. The bottom line is that FHE is the only technology that offers security plus verifiability plus composability. Yeah. It simply adds a layer of confidentiality to existing chains. I love that part, without changing how we build and use blockchains. You don't need to bridge to another layer 2 or another chain. It just works with existing chains. So that's the vision here. I want to ask you a cultural question because we're sort of having a bit of a moment here in crypto, I'd say. I mean, some people have called it privacy season. Not sure how long this lasts, whether this is a trader narrative, but it has been good. I think it's been kind of wholesome, actually, to watch Zcash rise in price, right? It's like, rather than go speculate on some stupid meme coin that a celebrity launched, right? Zcash, it's cool technology. It's going up. It has gone up 4,000% in the last 6 weeks, which has been pretty crazy. What do you think is driving this like focus on privacy? Is this a trader narrative, or do you think there's something deeper here in crypto?
I think there's something deeper. I think fundamentally people don't care more about privacy than they did before. I think one of the major driver is people started paying attention to finance moving on chain. Okay, we want dollar to be on chain. We want banks to be on chain. We want, we want the $100 trillion of assets to be tokenized and put on chain. But when you talk to financial institutions, they're just not going to do that unless they have confidentiality in their activity on chain. And so I think like the push and the adoption of blockchain by finance is what made people realize, oh my God, we need to solve the privacy thing if we want this to actually happen, and if we want blockchain to become the global financial rails of the world. So it was very honestly, like I think people were forced to look at privacy again as a kind of requirement for the realization of on-chain finance. And so the downstream effect of that is we get privacy as well as users, right, as people. But I don't think that the initial motivating factor was, I want to protect my data. I think the initial motivating factor is, JP Morgan wants to protect their trades on Ethereum.
Yeah, I think they do want to protect their trades on Ethereum. I think that's kind of the game theory of this. So if we have the tech now, the FHE tech and the confidentiality tech, and there's certainly the demand, institutional demand, retail demand, it's always been here. Let's bring back the nation state. Let's bring back the regulator conversation and address that. So during this privacy season, it's been interesting to observe. Just last week, there was a private Bitcoin wallet developer, the Samurai wallet, got 5 years in prison. He pled guilty to charges. That's in the United States of America. We've been following on Bankless over the last couple of years. The Tornado Cash Roman Storm case, of course, his case is still outstanding. I tweeted this recently, which is just like, I wonder how privacy developers are feeling. Developers behind the Aztec protocol, which is a ZK privacy layer 2. Developers even within your company at Zama, Rand, when it seems like the DOJ and the US government is somewhat arbitrarily picking out privacy developers and prosecuting them. Someone replied and said, well, look at the Roman Storm case. It was like, it's an okay outcome. I mean, he gets to present his case. Ruin that man's life. Okay, it's ruining his life. FBI raided his home in front of his daughter. Like arrested him. This is happening in the United States of America. And I'm kind of wondering, like, how you personally feel about this. Like, do you feel safe to develop privacy tools in the Zama protocol in the United States of America right now? Or like, what's the underlying feeling here?
So obviously, it would be nicer if we had clear rules to go by, right? Then you know what you can and cannot do. The way I think about compliance is that there are two ways to build a protocol. One way is I'm providing the privacy features directly, Tornado Cash, for example, and people are using it. The other way is what Zama is doing is we're providing a way for people to build confidentiality into their tokens and applications. The Zama protocol in itself doesn't offer any kind of privacy feature natively, right? We're just giving you a library that you can use to write a Solidity smart contract in which things can be shielded and things can be public. So it's kind of up to the developer and token issuer to decide how they want to be compliant. Ethereum didn't get sued because Tornado Cash was running on Ethereum. And so the way we're thinking about this is like, okay, so instead of like forcing a privacy model or a compliance model on everybody who's building on top of the Zama technology, we're going to create tools in the protocol so that people can decide how they want to be compliant at the level of their own users and application. So I'll give you an example. I'm a stablecoin issuer. I'm a regulated entity. I want to offer confidentiality to people on my confidential stablecoin on Ethereum. I would give the user the ability to see their own data, their balances or transactions, obviously, right? You want to know how much money you have. But I could also give myself, as a token issuer, the ability to see the data of my own users in my contract. And I can program that in my smart contracts directly. And if you're doing that, what you're recreating is TradFi compliance model. The user sees their bank account, the bank sees the bank account to their users, but your neighbor doesn't. And if you're creating this, like you're just recreating TradFi, then the token issuer can go and comply with OFAC and whatever they want to do. Like, it's their problem at that point because they're the one deciding the spectrum of compliance that they want to implement. And I think that's the key part. Programmable compliance at the application level. We don't force you one way or another.
Do you feel like that's enough of a bright line that you're not worried about this at all?
So another thing that we're looking at right now is a way to basically kick out applications that would be obviously used for legitimate purposes. So the way to do that is you're literally just like stopping the contract itself, and then people can withdraw their money, right? So you're never freezing the money or anything like that, but at least the application is no longer usable. I don't even think that this is necessary, to be honest, because the way I'm looking at this, most of the volume right now is starting to go through services that companies are building. And companies want to be compliant, right? So I think that it's kind of like the internet. 99% of the internet is compliant, and 1% is the dark web. And then most likely, as much as we want that or not, it's likely to be something similar with DeFi. 99% of stablecoins and DeFi protocols are going to be compliant stablecoins and DeFi protocols. And 1%, might be just like, not caring at all. We are building our protocol for that 99%. We're not building Zama for the 1% of North Korea money laundering use cases. And that's a choice we're making. We're very clear about that. Our business are legitimate financial use cases.
I still feel like there's something similar simmering here in the background. And we had Mark Andreessen on the podcast a couple of years ago, and he talked about the early cryptography wars and how the original cryptography behind kind of SSL, HTTPS was on the U.S. munitions list, basically. And so it he was like, it was not legal for him to export Netscape to Europe with those protocols in place, right? And so it took a while for the US to get its head wrapped around encrypted digital communications. And I don't feel like we've had the national conversation about encrypted financial transactions. Like that's another step. And it feels like the last administration, maybe members of the last administration, took a very dim view on financial privacy completely. And it wasn't just North Korea. It was just like, we don't want anybody to have financial privacy, right?
Well, I know I'm taking extremes just to illustrate the point, but in practice, of course, the people who are the most asking for confidentiality are the financial institutions. There is no chance that dollar stablecoins will be used as banking rails unless you have confidential balances and confidential payments. It's just not going to happen.
Agree.
Right? So again, I think, this is not like a Zama versus the US kind of thing or versus anybody else. This is like everybody has to come together and be like, we want this thing to exist. This is how we're going to make it happen. And we're going to follow along the lines of the people who need this technology, right? So Zama will participate as much as it can in helping to shape how confidentiality and blockchain can actually be built in a compliant, sustainable manner. As I said, I'm a founder building a company. So my goal is to do whatever is best for the people who are using my technology.
I think that's the way it'll work, honestly. And I think that's the way we got cryptography through the early internet. It was basically like, tech companies and said, hey, the internet's not going to work unless we have confidential communication, right? Anyone can browse this web traffic. You crazy? And the US government said, well, we want the internet to work in America. We're going to be pro-innovation, pro-building, pro-GDP, pro-job growth, and so therefore will allow this to happen. I think in the same way, institutions coming onto public blockchains, stablecoins, that's a big carrot for the US government.
Yeah.
I think that'll move the Overton window in our direction, but it's a dicey game to play right now. It's still feeling a little unsettled, and I worry about this sometimes.
I'm very confident that the way we're approaching the problem is the right way that we have to approach a problem. Like, we're not trying to pretend this is not a problem, right? But the good thing is, again, as I mentioned, people really want that.
Let's talk about Zama itself a little bit more. I think we've described it in a few places in this episode, but maybe we can put it all together because there is something going mainnet, I believe, relatively soon. Perhaps you can help us on the dates. And I think this is my understanding of it. Zama is a protocol, so it's a set of smart contracts. The very first place you're going to deploy these smart contracts, an underlying kind of protocol network, is Ethereum. And that is going to allow on Ethereum mainnet for confidential transactions. At some stage, I hope, and I'm sure that this is your intent, for the confidential transaction button to be in all of our crypto wallets via Zama. But this is going to mainnet relatively soon, correct? Like, can you tell us about that? What exactly is going mainnet and when, and what will we have the ability to do once it does?
So we are launching mainnet early December. So imminently, I would say, on Ethereum first, and then we're going to go multi-chain in 2026. The first use cases that we're focusing on are, I'll give you concrete examples, because I think it's always better to give you like clear app examples. So there is a company called Raycash, which is building an on-chain bank that cannot rug you. So the idea is that your money is on stablecoins on-chain. So even if they go bankrupt, you can always withdraw your funds to a different wallet, right? So like you own your assets effectively. But because you're using Zama, they can have confidential stablecoin. So your actual money in your bank account on chain is confidential. People don't know how much you have or how much you're spending, which is a very important point. But because again, they're using FHE, those confidential tokens are composable. So you can stake them to earn yield on your bank account. You can swap them for other crypto or tokenized stocks. You can also have, of course, a debit card and wires on top of it. So every single feature that you have from like a modern fintech app like Revolut, you can build on-chain with confidential stablecoins in a way that is completely self-custodial. That is huge when you think about it, right? That is absolutely huge because in a country where you've been rugged by your central bank or financial system, like I come from Lebanon. Lebanon a few years ago, central bank went, oh, sorry, no more money. We're freezing all of your dollars in your bank account. Boom, done. This would never happen with an app like Raycash if it existed. Cyprus in Europe a few years ago, Argentina, Nigeria, Vietnam. There's so many places where people cannot actually claim that they own their money. And this is a good solution to that. So that's one example. So that's going to be coming out relatively soon. Another use case that we're doing for Zama itself, actually, which I think is amazing, is a confidential vesting and distribution of tokens as a crypto team. You know, like I'm going to distribute tokens to the Zama team, to the Zama investors. We're going to do that with confidential tokens, which are going to be in an on-chain vesting contract, which itself is confidential. So, you know, your people don't know how much each other are getting, but everything is on-chain. Everything is vesting. That is solving such a huge problem that everybody has right now, which is like, oh my God, like how do we actually keep this information confidential? Because it's actually kind of like very private information. Like your salary is not something you want people to know publicly. There are also a bunch of other like things, but I think these two things are very interesting because they show you how simple things that we do today could be do much better on the same platform that you're using right now.
Can you talk about the diffusion of Zama and like FHE on top of Ethereum? So those applications and use cases sound very cool. The challenge with them is they're kind of like ground up. It's something net new, right? It's not something that people are using today. I think what people really, really want, like back to the Holy Grail conversation, is in my Gnosis safe or in my MetaMask wallet or in my Rabby wallet or whatever, when I'm depositing a position into trade in Uniswap or I am interacting with the Aave protocol, I want some sort of confidential button where I can go incognito and all of the existing apps and protocols and the existing Ethereum ecosystem just has that, has a confidentiality button by Zama embedded in it. How does that happen? Like, does every single app individually have to build this and opt in and put it on their roadmap? Or can this happen in a faster way?
We actually created a standard with Open Zeppelin and another company called Inco. We created a standard for confidential tokens, the ERC 7984, which effectively, standardizes that, specifically because we wanted people to be able to integrate something once and for all. The ERC 7984 token standard is not just for FHE, by the way. It works also for MPC tokens, it works for TE tokens, and to some extent, ZK tokens as well. So it's like a general confidential token standard. Of course, it's going to take a bit of time for people to start doing that because, it's like it's a new standard. So we are working today with multiple wallets who are currently integrating it. One of them that I'm using personally is called Braun. Fantastic wallet. It's not like one of the existing big ones, like a new one that just came out recently. And they did exactly that. You have like a shield button to convert your ERC20 to confidential tokens. And then you can do confidential transfers in a very streamlined kind of way. So I think it's just a matter of, it's going to take a bit of time for the adoption to kind of like take on like everything else. But for having been in crypto for such a long time, I don't think I've ever seen so much interest in adopting something new that just came out.
Yeah, certainly there's interest. So in that case, you would have to basically take your USDC ERC20 token, and then let's say Circle kind of adopted this or something. I'm not sure who would have to adopt this. Then there would be another ERC, confidential ERC standard that they would also support. You basically have to take your ERC20 USDC and swap it into the confidential ERC20 asset. Yeah. And then it would be confidential. Is that right?
Yeah, exactly. So you can shield and unshield your ERC20 tokens. So you can convert them back and forth to confidential tokens on Ethereum directly, right? So this is not happening off chain. This is like on Ethereum. So yeah, in the beginning, at least that's how it's going to be until confidential tokens become the default, right? And then ERC20 will be the exception when you don't have a choice but have to leave the confidentiality ecosystem. In the beginning, we're going from ERC20 to confidential tokens, but the same way that the internet is encrypted by default now, at least the HTTPS or messaging apps, the same is going to happen with tokens and transactions in the future. So public tokens is going to be an exception, not the default anymore.
Right. It wasn't always this way, right? There was a lot of HTTP that had to gradually convert to HTTPS, essentially, and that didn't happen all at once. That happened over many years, I believe. And so maybe something happens.
We have time. I think it's... I'm not building this as a short-term project. Privacy is something I've been working on for decades. And I think this is one of the most important things that anybody could be working on right now, especially if they're working in blockchain. And so however long it takes, however much resources we have to throw at it, we're going to make this happen. This has to happen. This is too important.
So if I have inside of my crypto wallet, if I have USDC and this is supported, and I then shield my USDC, what's actually happening in the background? Are there some smart contracts on Ethereum that are, I guess, getting triggered? Is the Zama network activated? Are there additional transaction fees to do this? Take me through the flow.
Okay, so let's say you have USDC and you want to turn that into confidential USDC. The first thing you have to do is shield those USDC by converting them to confidential USDC. So this is just a smart contract on Ethereum. So you're basically sending your USDC tokens to a smart contract, which then mints confidential USDC on the other side, right? So think of it like as a wrapping contract, kind of like when you have ETH versus wrapped ETH. Same idea, USDC to confidential USDC.
So there's some smart contract gas fees for this that are common to any sort of smart contract on Ethereum, yes.
So if you're on Base, for example, the gas fee will be zero, right?
Right.
Even Ethereum actually was 0.1 Gwei yesterday. So, it's never
Not
been
so
cheaper to use Ethereum. I remember, man, DeFi summer, 200 Gwei transactions. Like that was something else.
Yeah,
Anyways.
I see some doodles in your background. So I don't know if those were purchased with, very high gas fees, but yes, I'm sure you understand.
Yeah. So that's the first thing, right? So you shield those tokens, just as transactions. So you pay whatever fees on Ethereum, you have to do that. Now that you have a confidential USDC token, you want to be able to send that to someone confidentially. When you want to send tokens confidentially, you need to encrypt the amount that you want to send.
Okay.
So to encrypt it, you need to use the public key of the Zama protocol. So you're encrypting it, but you also have to pay a small fee to the Zama protocol to prove that you've used the correct encryption key to encrypt the inputs. So basically, the Zama protocol has to verify that you've done the encryption correctly. This is actually one place we use ZK, by the way, right? You produce a zero knowledge proof of the encryption that you've done, and then you request a verification for the Zama protocol. And here you're paying a small fee with Zama tokens.
And that's where it's going to, I don't know if I should call it the Zama network.
The operators, yes, exactly.
The operators, yes.
Yes,
okay.
Exactly. So when you do that, you're sending that, the operator has verified a proof, they send you back an attestation. And this is what you're including in your transaction to Ethereum to say, hey, this is a proof that I'm allowed to send this encrypted amount. The contract does this thing. And then when you want to decrypt your balance, again, you just call the Zama protocol, paying a small fee for the decryption. And that triggers the MPC threshold decryption, and then you get your balance back. Okay. So we don't charge for the computation. We charge for the basically encryption and decryption of data.
Very cool. So while it's confidential, I suppose there's no charge. You just charge, when it becomes confidential or when you're decrypting it.
Anytime you're encrypting data in a transaction or decrypting data that's on state, you pay something. But the actual transaction on the L1 or L2 you're using, you just pay the gas fees of that L1 or L2.
Very cool. And that the operators that you were mentioning, those are the 13 entities that we were speaking about earlier. Is that correct? And they're running some sort of Zama infrastructure basically to do this encryption and decryption. And of course, it takes a 2/3 majority for them to decrypt anything. Yeah. And so I'm sure reliability, uptime is important. Yeah. I'm sure that these, I don't know if I should call them validators. I'll call them operators, maybe.
Operators, yeah.
Okay, yeah. So these operators have to have some uptime guarantees and certainly have to be, like credible, high reputation entities. So how does that side of the network work, and how are they incentivized?
So they have to stake tokens.
Okay.
And so it's a kind of traditional proof of stake type thing. If you cheat, if you're down, you can get slashed, all that kind of stuff. And they get rewarded by Zama tokens as well. So users are paying fees for encryption, decryption Zama tokens, and then we're also giving rewards to operators who are staking in Zama tokens. So the Zama token is a very vanilla utility token used for fees and rewards, effectively.
I was going to ask about this. So the Zama token is coming out soon. Yeah. It's not out yet, but that's going to come out with mainnet because you need this for operators. Is that right?
Yeah. Correct. Yes. So we're actually launching the mainnet with the Zama token and everything early December. So any day now.
Very cool. All right. In what conditions does an operator get slashed? What types of bad things could they do to get slashed?
That's a pretty open-ended conversation. Depends who you're asking. All right.
Okay.
The way that we're addressing slashing in the Zama protocol is actually through governance. So we think, there are different situations and people can, they can be offline for different reasons. Maybe their data center blew up, right? Like in that case, it's technically not their fault if that happens. So instead of just having like a blanket slashing for any reason whatsoever, the idea is that the operators between them can effectively look at what happened and decide what's the appropriate course of action. Should we just, kind of like consider that to be like a one-off bad luck kind of issue? Was this malicious intent? Should we kick this operator out, right, and replace them by someone else? Should we slash them? Should we, pause their rewards from some amount of time? So we're basically using like a governance system to decide the appropriate thing. Kind of like, it's like a jury in a way, right?
Can you maybe contrast this and thinking again from a user perspective from other privacy solutions that are available on Ethereum today and kind of the pros and cons or how this would work. So on Ethereum today, I could, actually, I don't think I can use Tornado Cash legally anymore, or they may have taken that off the OFAC sanction list. I'm not sure.
I think they took it out, but I think it's still frowned upon.
Yes. Okay. All right. So something like Railgun, right, which is a privacy pool. It's not on the OFAC sanction list. And so basically, it's somewhat complicated, but you can kind of like shield your transaction that way. Does require some gas fees. That's one possibility on Ethereum. There's other privacy pools as well. So there's the privacy pool type of camp.
Yeah.
And then there's something that Aztec is rolling out. They're going to mainnet soon. This has been a long-awaited Ethereum project that's a layer 2. It promises privacy. I don't really have a sense for how that's going to feel from a user perspective, but I guess my guess is it'll feel somewhat like bridging to an L2, right? It'll be that whole experience. And then when you're on the other side of that bridge, you kind of enjoy, privacy for everything, but you still have to go through the bridging process, and it breaks composability, it breaks liquidity. So those are the two general streams of options I see on Ethereum for privacy and confidentiality. You're adding a third. So how will the third feel for users compared to those other two?
It'll feel just like using Ethereum, right? For developers, it'll feel like just like building for Ethereum. Everything is in Solidity, and you're pushing your contract to Ethereum. For users, everything's going to feel like Ethereum. You're using a wallet to make a transaction to Ethereum. And that's really how we thought about this, right? We don't want people to use something else. We want people to use Ethereum confidentially.
How confidential is this? So we've talked about sort of the encryption, decryption side of things. I'm fine there, but in the process of going from unshielded to shielded, am I leaking any other data in that process? Is there other stuff
I guess when you're shielding, it's a public operation, so people know how much you deposited as confidential tokens.
Right.
I mean, same thing if you're bridging to a privacy chain, or even to Railgun, like the deposit is public. Once it's shielded, then everything is confidential. So of course, the idea is that people never unshield, right? It's like, you shield once and then that's it. But even that, to be honest, I'm a little bit, I don't like it, right? The fact that the shielding is public. So what we're currently working on is finding ways where you can have on and off ramp with confidential tokens. So when you're getting a stablecoin minted, you would get natively a confidential stablecoin. So there'd be no shielding necessary. When you deposit tokens to an exchange or withdraw from an exchange, you deposit and receive confidential tokens. So technically, you could use an exchange as a way to rebalance between multiple addresses, right? If you have this confidential on and off ramp, then the shielding thing is no longer an issue.
Very cool.
I mean, arguably, Coinbase would see how much you have because you send them the confidential tokens, but that's an acceptable trade-off, I think.
This is what you've just described is the thing that's coming to Ethereum mainnet and then to other chains later next year. That's the Zama network, the Zama protocol. There's also, my understanding is there's other projects using Zama technology and enjoying some of the benefits of FHE and what you guys have developed, but taking it in a different use case, in a different direction. I'm not familiar with many of these, but one I'm somewhat familiar with is Fhenix. And my understanding is they were originally an L2 that was completely private. Maybe they've moved to being sort of a co-processor now. Maybe use Fhenix as an example of how are they using FHE? And I should say it's Fhenix with a FHE, Fhenix, not PH.
Good work,
Fhenix. So what's that doing? What's that project up to?
I mean, I know the team at Fhenix very well. We're very close, and they're one of the best teams in privacy. Guy, one of the founders, this is his third privacy protocol.
Guy, one of the founders. The other co-founders also named Guy, which is kind of fun.
Yeah. So these guys, I guess. Right? so one of them, Guy Ziskind, he started Enigma, which was an MPC confidentiality protocol.
I remember that.
Then he started Secret Network, which was also a confidentiality protocol. Now Fhenix. I think he's one of the very few. He must be the only one who launched 3 privacy projects. Like he knows what he's talking about. Like this is a serious guy. No pun intended. That we're talking about.
It's 2 serious guys,
right? And the other guy actually was working at Intel on FHE stuff. So like also coming from like that field. Honestly, I would say that like, for us, they're one of the best teams out there, for sure. And so they're using Zama's cryptography to build their own confidentiality protocol and coprocessor. So it's the same underlying FHE tech, but it's a very different instantiation that they've built on top.
Interesting. This has been very helpful, Rand. I've really enjoyed this. Maybe often I think conversations with founders about projects like this start with like, hey, what's your bio? And you're like, what are you doing? I wanted to get right to the meat of like what you're actually doing for confidentiality and crypto. I feel like we've done this. So now we can get to the bio part of the episode, because you have a very interesting, like the way you got here and what you've been up to in life is pretty interesting. So you have a bioinformatics PhD. You've also been in crypto since 2013, since the early years. You also, my understanding is you have some interest in kind of the degen side of things, like meme coins, and I see some NFTs in your backgrounds. You're doing all of that. You're also involved with like longevity and biohacking. I don't really know where to start in this like set of questions, but like, you tell us a little bit about yourself. Like, what are you up? What are you up to? How'd you get here?
I started coding when I was like 10 years old. Built my first company as a teenager in the 90s. It was a social network at the time. And that's actually, by the way, when I started caring about privacy the first time, because when you build a social network and you see the amount of personal data you're collecting, you're like, oh my God, this is wrong on so many levels. And then eventually ended up doing machine learning, did a PhD in AI applied to biology, bioinformatics. I loved bio and AI. For me, like bio and data was always like two of my favorite things to work on. Decided to go down the route of AI and built one of the first AI companies in Europe, already focusing on privacy, which is where I discovered FHE and met my co-founder, Pascal Payet.
When was this, by the way, when we were doing that AI thing?
2015 to 2019. Okay,
so this was before the whole LLM breakthrough.
Yeah. Actually, I sold that company in 2019.
Oh, wow.
In hindsight, good timing, because now that I see what it took to build AI, I mean, we didn't have the funding to do that at the time, clearly. Like, we were thinking...
Not a hyperscaler?
We were thinking tens of millions, not billions.
Yeah, right. It's in the trillions now, I'm pretty sure, right?
In the trillions now. So that went great, made a bunch of money selling that company. And so since then, I've been investing also quite actively. So like I've invested in about 100 companies. I like to invest in super deep tech, complicated projects. So my kind of like line to founders is, if they go to a VC and he doesn't get it, they should come and pitch me instead. Right? And so, so crypto since 2013, mostly like on the, as you said, investor, trader, degen side. This is my first crypto project as a founder, for sure. So like, I would say like, it's not, well, privacy is obvious because it's something that has been like a red thread in everything I've done. But to be honest, Zama could have gone the way of confidential AI or the way of confidential blockchain. And in fact, for a time, we were building both. It's just we found that the need for confidentiality in blockchain was much more urgent because there is no other way to build those use cases we want to build with finance.
Maybe come back around to AI at some point. I'm having the founder of Proton, the Proton Mail and the suite of services there.
Yeah, of course.
And one of the topics I want to discuss with him is like, hey, what's the state of AI privacy? I mean, they rolled out sort of a AI privacy sort of feature inside of the Proton ecosystem. Yeah. What's your take on this? I'm deeply worried about it. Like as a daily ChatGPT user, I'm like, I've read the terms and service. No, I had ChatGPT read me the terms and services for terms of service for ChatGPT. And it's not great. Like different people with different access can get your information in ChatGPT. I mean, like when I talk to a doctor, there's things like HIPAA, right? There's confidentiality that I have baked in. If I talk to a lawyer, I know the lawyer is not going to sell me out. I know it's going to be confidential. And people are having these conversations with ChatGPT and have no idea where the data is going and what their civil protections of that actually are. Can we change that? Like, what's your assessment of the current state of AI and privacy?
I think is going to happen. So, I know a lot of the AI founders just, by virtue of being early in the space, right? Everybody wants confidentiality in their AI products.
The founders do.
Yeah, the founders do. Yeah, they do.
They don't. You think they're genuine in that? They're not trying to data mine us and steal our data.
No. 100%. Like data is toxic for a company. It's liability, right? People need it to offer a service, but nobody wants it, right? If people could offer a service without having access to the data, they would.
But isn't that service ads? Don't they want our attention, our eyeballs? They want know everything about us so they can sell us more stuff?
You can do confidential advertising. Right?
Okay.
Like, the point is people want things like FHE for AI, but it's just that right now, the way the AI industry works, the compute is the size of the model are so big, and they're already like so limited in how much compute they can access. Like there's not enough energy, electricity production in the US for AI demand, okay? They cannot afford any extra computation cycles for confidentiality. So right now, the economic model of AI doesn't allow you to bake in confidentiality, even if it worked. So until we find a way to make AI models smaller or to make GPUs cheaper and less energy consuming, it's going to be very difficult to make that happen. So it's not a question of whether people want it. It's just a question of economically right now is just infeasible.
So it's basically back to a tech problem again, right? Back to why we haven't had confidentiality and privacy in blockchains. It's not because the demand isn't there. It's not necessarily because of regulators. It's because we don't have the tech and scale to actually pull this off.
I'm convinced, to be honest, that, the same way that we went from no encryption to encrypting data with HTTPS, we're going to end up encrypting data in end-to-end in everything we're doing, including AI, including blockchain. And the day that's going to happen, nobody's going to care about privacy, not because they gave up, but because it's going to be by default in everything we're doing. And that's the end goal. Like when I think about Zama, when I think about FHE, when I think about all of these technologies, I don't just think about it for blockchain. I think about it as like a technology for everything that you're doing on the internet down the line. Blockchain just turns out to be a great way to start.
Rand, I was just re-listening to an episode we did with Brian Johnson, Don't Die. Are you in the kind of the Brian Johnson camp of longevity? I actually haven't read. Yeah,
I am actually. So my latest longevity score is 0.68.
Wait, what's a longevity score? What is that? Is that called the Dunamp ranking for this term somewhere?
The Dunedin pace. So basically, they measure the pace of aging. So how fast are you aging versus calendar months of the year? So if you're like, 0.68 like me, it basically means that like, you're aging 0.68% of a full year per year, effectively. So like you're aging slower, which is great because, 0.68 puts me like in the top 20 on Brian Johnson's leaderboard.
Wow, you're really listed on the top 20 of Brian Johnson's leaderboard?
They haven't updated my score yet, so I'm like in the top 50 still. But when they update my latest score, it will be the top 20. Yeah.
Oh my God! So you're serious about this? You are a longevity athlete, sir.
Oh, dude! Like I'm like full on biohacker, like competitive biohacker, right? It's a thing, man. Competitive biohacking is a thing.
How often do they take this score, or do you submit the score?
I do it once every quarter.
Okay. Is there some ability to game it? Like how do they verify the integrity of the data?
So the company that does the test uploads the score.
I see. Wow.
Yeah.
And are you Brian Johnson? It feels like he's doing this 24/7. It doesn't seem sustainable for the regular person.
I tried doing that, man. I tried both ways. I tried to be very unhealthy at some point. I did an experiment. Yeah.
Well, you tried to be unhealthy?
Yeah. So I wanted to start a company doing AI for nutrition. But the problem is I was fit. And so I needed to find a way to be unfit to get fit.
So you did a supersize me thing.
I did a supersize me. I gained over 70 pounds in a year. That was a lot. That was a lot. And then my mom started freaking out. She was like, please, I beg you, stop. I was like, no, I'm going to. And then I stopped. And then a year later, I got fit again. And then at some point, I was like, you know what? I want to try the other way around. Like, what does it take to get ridiculously fit? Like, to a point that makes no sense.
Yeah.
Well, I called up a friend of mine who's a coach in LA, and I told, hey, Mike, what are you going to do for the next few months? He's like, not much. I'm like, come to Paris, live in my house, and train me, for 6 months, like hardcore style. So for 6 months, I had a live-in coach that was basically training me everything, food, workouts, mindset, like every single thing 24/7.
Wow.
So obviously I got like extremely healthy and ripped, but it was, 20 hours a week of efforts going towards that. So completely not doable when you're building a company. And so now it's more like an 80-20 rule. So I do 20% of what I used to do, but I still get 80% of the benefits.
Yeah, to be able to be a founder and fully dialed into that, and then also top 20 longevity score. I mean, you must have found some secret combination here.
Yeah, well, I mean, it's actually not that hard if you know what you're doing. So there are 6 things that you have to figure out first. First, sleep well, eat well, exercise, don't smoke, don't drink, have friends. I swear, these are the 6 things.
That's it?
That's lifestyle-wise, that's all you have to do.
And that helps you live longer. That will increase your longevity.
You'll get to 100. Just that, right? Then the question is, how do you get to 120 or more than that? That's where you get into supplements. That's where you start getting into biotech, into interventions and protocols, as Brian, calls them. So my protocol is pretty simple. Like I'm basically optimizing for immune system, for blood flow, and for energy metabolism. The logic being that your body knows how to fix itself. So if you have a good way to fix it, enough energy to fix it, and good blood flow to make it kind of like spread around, let the rest happen naturally, biologically.
Are you fully on board with the whole you don't think you're going to die type of thing? Like, do you think you actually could live forever?
Well, I'm certainly hoping that technology will get us there. But I do have a plan B in case it doesn't happen, which is being cryopreserved. So, worst case, there's someone's going to put me in a nice box and wake me up in 1,000 years. Who cares? You're dead anyway. You don't see time pass. I've invested in that company, by the way, because I was like, look, if I'm going to be a customer, I might as well know that this is legit. Great company based in Germany called Tomorrow Biostasis. I know it seems like far-fetched, but look, it's a plan B, right? Plan A is live for as long as possible, healthy, happy. Plan B, you get hit by a bus. At least, you have a tiny, tiny chance to make it back.
If you're living for hundreds of years, do you think this can be achieved like biologically, or is there going to have to be some silicon biology sort of fusion? Are you envisioning a world where maybe you are encrypted inside of a data center somewhere? You're like, your mind is there. And, hopefully it's encrypted, right? Hopefully it's got some FHE behind that, so someone can't hack your mind.
I think there is the camp of like mind upload, right?
Yes.
Clearly. I'm more in the camp of like fixing biology, like you fix a car.
You kind of like your body the way it is.
Yeah, keep it the way it is. Maybe replace a heart here and there, right? But like at least preserve a biological kind of like baseline. That's what I want to do, right? Like maybe it's fun to be in a computer, but I don't know. I just think it's fun to be here right now talking to you. So I want to keep that going as much as I can.
Yeah, that's my feeling too. I mean, I really like blockchain. I'm not sure that I'd want to live inside of a blockchain, whatever that would mean in the future. Rand, this has
imagine, coming back as a meme coin, like how
that'd be called hell, I think. Yeah. Rand, this has been really fun. Maybe just last question for you. 2026, what progress do you think crypto is going to make in terms of privacy and confidentiality? What should we look out for?
I think 2026 is really going to be a turning point where privacy, Zama hopefully, but also other things are going to go mainstream and are going to start to be integrated by default. I think every wallet, every exchange, every DeFi protocol, every stablecoin is going to have a confidentiality feature because it's net better for everybody to have that.
That is good. That is bullish. That is great news. Thank you so much for joining us today. Bankless Nation, got to let you know, of course, none of this has been financial advice, though. If you do have finances on the blockchain, you'll want to make sure to keep them private. You lose what you put in, but we're headed west. This is the frontier. It's not for everyone, but we're glad you're with us on the Bankless journey. Thanks a lot.